So then the other element that you need to understand set theory is the application of Venn diagram in word problem sort of it, right? So let's say I'm talking about is a school, right, which has some students. Let's assume there are n number of students in that school. That's like the entire list of the students in the school. And some of them play football, some of them play cricket, and some of them does not play any game, right? They play neither cricket and neither football. So how does that picture look like? So all the students who play football, I call that set A. All the students who play cricket, I call that set B. So let's assume this blue is set A and the red is set B. So this is the universe. Universe is basically all the students in the school, right? All the students in the school. So I am expecting there will be some students who will play both. That is, this zone is, I am calling it X. That is X number of students which play both cricket, football and cricket, right? And then let's say this zone, right? This entire circle is people who play football. If I remove this circular zone which actually includes people who play football and cricket, what would this be left? This is people are students who play only football, right? Understand this clearly. This is an important understanding to have. This entire circle is people who play football. Who play football as two types of people. Some people only play football. Some people play football and cricket. Football and cricket is this zone, right? Because that's overlapping with the cricket players as well. So that is X. Only football is this zone. Let me assume that to be equal to Y. And then what will this be? This entire circle B, the orange or red circle, is people who play cricket. And I know that these people play cricket as well. Obviously for cricket also it will be two, right? Only cricket or football and cricket. And obviously I know football and cricket is X number of people. So let me assume this only cricket is Z. So basically this is Z, this is Y, and this is X. So these are the three areas I have, and the remaining thing which is not shaded per se, the one which is outside, right, this part I'm talking about, this would be the entire universe minus these three. That is people who play neither cricket nor football, right? They don't play either of the games, right? So universal set is the total number of students in school. Let's say I take this to be n, right? The entire number of students in the school is n. We'll rather get the numbers in the questions, but I'm going with the variables to just explain this clearly. So number of students who play only football, according to our diagram, what is that? That is, who play only football is Y, right? The number of students who play only cricket is Z. The number of students who play both cricket and football is this zone, that is X, defined as X. So number of students, let's come to this part. Now if I ask you, right, if I know these things, okay, let's assume I know these numbers or something. So the number of students who play football is, as I said, people who play football is play only football or football and cricket. That is, only football is Y and X is the people who play both. So X plus Y is the total number of students who play football, right? I'm basically adding this and this, both the parts, so that I get the entire circle. Similarly for the circle B, which is the number of people who play cricket, I need to add Z and X so that I get people only play cricket plus the people who play cricket and football. So this will be X plus Z. Right, and what will be the number of students who play cricket or football? This is like basically talking A and union B, right? At least one of this, right? Even if they play one of these two games, that's fine for me. That's why it's asking number of students who play cricket or football, right? That will turn out to be Y plus X plus Z, right? The number of people who play only football, number of people who play both, and number of people who play only cricket. If I add all three of them, I should answer this question, which asks the number of students who play cricket or football. Finally, the number of students who play neither cricket nor football, what would be that? The entire universe, basically n number of students is what I assume, right? Let's assume the number of students is n. From this, I have to eliminate the people who are playing, cricket or football. So I just need to eliminate x plus y plus z. So that would give me this entire zone, right? These two circles will have y plus x plus z number of students who play. So I have to remove these two circles from the entire universe to get the people who play neither cricket nor football. That would turn out to be n minus x plus y plus z. Generally, is y, x and z is what you need to assume. Then they'll give you some hints in the question. Just write the equations based on it, solve them, and you will be able to answer the question. But given clues will be given like this: the number of students who play only cricket, the number of students who play both cricket and football. You just need to understand what is this they're referring to. Is it only this part, or this is combination of both, or is all three areas, etc. So immediate thing that you need to see whenever you see two diagrams with two circles is this is like y or x, z. Understand this and then solve the question based on the clues and find those values, and you'll be able to answer the question. Now let's get to the Venn diagrams. In a survey, it was found that 60% of the respondents like pizza and 50% of the respondents like pasta. What percentage of the respondents like both if each respondent in the survey likes at least one of the two items? So that means I know that each and everyone in the survey would like at least one of these two. So I have two circles. So the universe itself is this. All the 100% of the respondents would fall in this. As I said, I'll like x, y and z. As I said, because I know each and every respondent in the survey likes at least one of these two items, if I add them, that should be equal to, in percentage, you can write in the percentage and solve everything and you get the answer in percentage itself. Because any other question is also asking in percentage only, right? Why did I do x plus y plus z is 100%? Because I know each respondent in the survey likes at least one of the two items. So they should either like pizza, let me call this to be pizza likers, and this is pasta, and this is both. So they like pizza or pasta or both. So they have to fall in one of these three categories, and I know all of them have to make 100% because each respondent likes at least one of them. What is the other clue? They said 60% of people like pizza. So what is the pizza, what number of people according to the variables? X is only pizza lovers and y is pizza and pasta. So I have to add both. So x plus y is 60%. And finally, pasta lovers is 50%, and that will be y and z, because only pasta lovers is z and both pasta and pizza is y. So that will be y plus z is equals to 50%. Right? Basic rule in algebra: 3 variables. I need to have 3 equations to solve and find the individual values. Right? So to get a unique solution. So simple. Let me add 2 and 3. What do I get? X plus y plus z is equals to 60 plus 50%. This is 110%. X, y and z, they will come together, plus y. From the equation 1, I know x plus y plus z is 100%. So 100 plus y is equals to 110. So y is 10. Once I know y is 10, what is z? 40%. Right? Y is 10%, z is y 40%, and obviously x is 50%. What is the question asking? What percentage of the respondents like both? So that's basically both is y. That's why it's 10% is the answer for this. Right? That's how you can solve it. As I said, just note the variables properly, write the equations given as per the clues, and you should be able to solve it easily.